Hi friends, this is Salvajan here. Welcome to my networking channel. Hope all are doing good and safe. And today I'm going to show about EIGRP equal and the unequal cost balancing. So what is the equal cost balancing? By default, EIGRP can load balance across equal cost path. That means yes, they assume all this path R1 has three path, right? 1, 2 and 3 for reaching this network 5.0 network. So for if all are having the equal metrics or equal feasible distance, what happen? It can load balance across 2 to 3 paths. So maximum it can support up to 6 equal path. EIGRP can support load balancing. So even EIGRP can perform load balancing across unequal cost metric. That means each and every link it is having the different bandwidth value or it is having a different metric value. Still EIGRP can perform still load balancing across unequal metrics. So that we call as an unequal metrics. So that is done by means of parameter what we called as a variance. So variance parameter values ranges from 1 to 128. So one is variance, one is for equal cost balancing and variance 2 to 128 is for a unequal cost balancing. So I can assign the range 2 to 128 any value to perform the unequal load balancing. So for example, this I assign the value 128 and this I assign the value bandwidth is 256, right? So based on the different metrics, still EIGRP can perform the load balancing, what we called as a unequal cost load balancing. I am going to show both equal and the unequal cost balancing. So now let us go to the individual router and quickly enable the routing protocol EIGRP. So router EIGRP 100. Let us do a shotgun approach. Network net 0.0.0.0. Similar way, go to R2, go to the configuration mode, and let us enable the routing protocol. Router EIGRP 100 and the network is 0.0.0.0. So this will define all the networks in EIGRP and go to the configuration mode. Router EIGRP 100 and the network is 0.0.0.0. Similar way, go to R4 and configuration mode and router EIGRP 100 is network 0.0.0.0, right? So I define all the networks on R1, R2 and R3 and R4. So now we are able to see the neighbor statements are coming up, right? Neighbor relation is coming up between R1, R2, R3 and R4, right? So now what we can do, now let us check the EIGRP topology table. Show IP EIGRP topology table. And let us take this network 192.168.5.0 for R1 to reach this network. There are two paths you are seeing, right? 2.2 and 3.2. One is 2.2, 2.2 and 3.2, two equal paths you are able to see because both are having the equal metrics. FD you are able to see, right? 284160 and this also having the 284160. So both are having the equal metrics. Now it will be showing both the path in the routing table. So that we call it as a equal cost balancing. So it is load balancing across equal metrics, right? Both are having the same metrics. So you are able to see the same routing table. You are able to see the two different paths, right? Because of the equal load balancing, because both are having the same feasible distance, same metric. So similar way, I can even load balance across 3 or 4 equal paths. So that is the benefit of EIGRP load balancing. And for this equal load balancing, the default variance value is 1 always. So the variance parameter value is 1. So how I can set it to maximum value in a unequal cost load balancing? So what I'm going to do, I'm going to change the metric value. So I want to show you about unequal cost balancing and how using variance I can perform unequal load cost balancing. So let us assign this value. Fast Ethernet 0/0 is 128. Go to the configuration mode, interface, fast Ethernet 0/0, bandwidth, let us set it as 128. So you can set any parameter value. So just I want to show the unequal load balancing. That's the reason I'm setting this value. So this one I'm going to set it as 256. So go to the configuration mode, interface fast Ethernet 1/0 and the bandwidth I am going to set it as 256. So I already told based on the k values it will set the metric, right? So here the k1 is 1. So k3 is 1. This is bandwidth and delay. So based on the bandwidth and delay metric, it will compute the distance, right? It will compute the metric. That is a composite metric. So based on the metric, we are able to see in the topology table. So now you change the metric. So now let us check the EIGRP topology table. So now it will change. It will vary again. So there are three paths you are able to see, right, in the topology table, right? For reaching this 5.0 network, there are three paths. One is 1.1.2 and another one is 3.2 and another one is 2.2. So there are three different paths you are able to see, not equal metric, it is an unequal metric, right? So this is having a different FD, and this is a different FD, and this is having a different FD. So if I want to check the routing table, let us check the show IP route EIGRP. So you are understanding, right? So without the variance parameter, so it is an unequal metric. Both are all the three paths. It is having the unequal metric, that is a different FD value. So what happened? Only the route with the least feasible distance, that is 309760, right? This is the least feasible distance will be always installed in the routing table for reaching this 5.0 network. So the least feasible distance here is 1.2, right? So 1.2 is the least feasible distance. So it is 1.2 network. This is the least feasible distance. So that will be always installed in the routing table. So how I can make all the paths? I want all the paths to be load balanced. So I also want to show in the routing table. So for that reason, I am going to configure the parameter variance. So how we can calculate the variance value is 2002, this value divided by the least value. So if you are dividing this value divided by this value, you will get the value. So that value I'm going to set it as a variance parameter. Always highest value divided by the least FD value, right? So this is highest feasible distance and this is the least feasible distance. So now let us go to the configuration mode and router EIGRP 100. So variances, so this divided by this is 65. So the variance I'm going to assign as 65. So I already told variance 1 is for equal cost balancing and 2 to 128 is for a unequal cost balancing. So this value I'm assigning. So now let us check the topology table. Show IP EIGRP topology. After assigning the variance, so these are three paths already we are seeing in the topology table. So now let us check the routing table. Show IP route EIGRP. So now you are able to see, right? It has load balance across different path with the different metrics. So each and every is having different metric. This is having 256, this is having 128, and this is having the different default metrics. So based on the bandwidth delay combination metric, right? So it will calculate all the feasible and the advertised distance. This is feasible and the advertised distance. Since I have used the parameter variance for unequal cost balancing, it has load balance across three different paths with the different metrics. So this we call it as an unequal load balancing. So equal cost balancing, the variance parameter is 1, and for unequal cost balancing, the variance parameter is 2 to 128. So between 2 to 128, I can assign any value, right? I hope you understand this video. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.